digital voltmeters. Here, digital voltmeters in the name itself had digital. That means the voltmeters represents the values in digital form. Whenever the output will be digital, obviously the input will be analog. That means it converts analog signal to digital signal and displays the voltage value in digital form instead of pointer deflection. That means we are getting a digital value whatever it may be. Suppose if the value will be 4 volts, we will get 4 volts, but in analog it will represent 1 2 3 4. We have to count the value and we have to observe carefully and we will know the values. But in digital voltmeters there will be no problem will be occurred like counting or whatever it may be. సో అంటే ఇక్కడ అనలాగ్ వాల్యూస్ని మనం డిజిటల్ వాల్యూలోకి కన్వర్ట్ చేస్తుంది. సో దట్స్ వైజ్ వీ కాల్ ఇట్ యాజ్ డిజిటల్ వోల్ట్మీటర్స్. అండ్ ఆల్సో దీస్ వోల్ట్మీటర్స్, దట్ మీన్స్ దిస్ డిజిటల్ వోల్ట్మీటర్స్ ఆర్ ఆల్సో యూజ్డ్ టు మెజర్ AC DC. Both AC DC can be measured by using this, and also we can measure like pressure, stress, temperature and etc. These type of quantities also can be measured by using this digital voltmeters, but we have to use proper transducers and signal conditioning circuit. Proper transducers and signal conditioning circuit are used to measure this stress, temperature and pressure, and also it reduces parallax errors. Whenever we are getting a proper number, that is 4 volts, we are getting a approximate value, then there will be no errors, no error will be present. In analog meters there will be errors. మనకి అనలాగ్ మీటర్స్లో ఖచ్చితంగా ఎర్రర్స్ ఉంటాయి. ఎందుకు అంటే అనలాగ్లో మనమే కౌంట్ చేసుకుని వీ హ్యావ్ టు అబ్జర్వ్ కేర్ఫుల్లీ అండ్ వీ హ్యావ్ టు నోట్ ద వాల్యూస్ వాట్ ఎవర్ ఇట్ మే బీ. బట్ వీ విల్ గెట్ సమ్ పారలాక్స్ ఎర్రర్స్ అండ్ వీ విల్ గెట్ హ్యూమన్ ఎర్రర్స్ ఆల్సో. బట్ ఇన్ డిజిటల్ మెథడ్స్ వీ వోంట్ ఫేస్ సచ్ టైప్ ఆఫ్ ప్రాబ్లమ్. ఆ ప్రాబ్లమ్స్ మనకి ఉండవు. So it reduces in digital voltmeters. The most advantages is the reducing errors, and there will be a reading speed is very high. We can read the values at a time. Instantly we can read the values. Okay, now block diagram of digital voltmeter. Let's see the here ADC is used here. ADC means analog to digital voltmeter converter. Analog to digital converter, and every ADC will contains the reference. So here analog input is giving and we will get the output as digital, and this digital output is giving to the signal processing. Manam analog input ante ADC ante obviously the input will be analog, so output will be digital. The digital output ni manam signal processing ki istunam. So this signal processing will process the signal and gives to the data transmission element, and finally this data transmission element displays the value on the display. Okay, here every ADC requires reference will be required for every ADC, and here reference is generated internally, and here manaki tells ADC, every ADC requires a reference annam, and e reference anedi depends upon the ADC which we have used. Mana a type of ADC ni aithe use chesamo aa ADC meeda maniki reference generator will be depends, and output of ADC is decoded and signal is processed in decoding state. Finally the output will be displayed on the display. And coming to classifications of digital voltmeters, there are 3 types. One is successive approximation, another ramp type, and another one is dual slope integrating type. In ramp type there are 2 types, linear type and staircase type.